All right, Mr. Ahmed here for 2.5. Essential question for today is how do I solve compound inequalities? And our compound inequalities are going to be an inequality formed by joining two inequalities using either the word and or the word or. So, some examples. I'm going to start with and then you'll see that on the next page we'll go over the ors. So we're just going to hop right in. An and compound inequality is a compound inequality that's formed by using the word and. The graph shows the solutions that make both inequalities true. So it'll make both sets true. And our example will look something like this. I could have x is greater than 1 and x is less than or equal to 5. All right. The other way to write that is without using the word and x will go in the middle, the smallest number to the left, the bigger number to the right. And then we will have to fill in our inequalities going the same direction. Okay. So x is greater than 1. Notice x was being eaten instead of 1. And x is less than or equal to 5. So essentially, all of the numbers that are going to make that true are all of the numbers between 1 and 5. And since 5 is also a possibility, it could also be 5 because that's an or equal to. All right? So first thing we're going to do is practice writing it without the word and, because that is the most common way that we will see it. So again, when I do it without the word and, we start with the smallest number. In this case, the smallest number is 5. The bigger one's 15, x in the middle. Now we look and see which ones get eaten. Between the 5 and the x gets eaten, no or equal to. So x is bigger than 5, and the 15 is getting eaten, or equal to sign. X is less than or equal to 15. Try our next one. Smallest number is -3, x in the middle, bigger number is 10. Notice 10 is being eaten, bam, and x is getting eaten over the -3 because x has to be bigger. So x is greater than -3 and x is less than 10. So, solving. When we solve these compound inequalities with the word and, we need to isolate x in the middle. So the first one's already done. X is by itself. So our solutions are between -4 and 6. When you draw this up, don't get too carried away. This one's pretty small numbers, so I'm going to do a good job. -1, -2, -3, -4. I counted over. At -4, have to look at this both ways. X is bigger or equal to closed circle. So closed circle at -4. Then I have to go over to 6. 1, 2, 3, 4, 5, 6. Barely made it. Closed circle again because it's or equal to. And with an and, typically we're going to shade in between our 2 points because x is bigger than -4 and it also has to be less than 6. So all the numbers between -4 and 6 are solutions to the inequality. So like 0 makes sense. If I put 0 in, -4 less than or equal to 0, less than or equal to 6, yes, 4 is bigger, or 0 is bigger than -4, and 0 is less than or equal to 6. Okay, the next one we're actually going to have to solve, and we have to isolate the x. So to get rid of the 2, just like when we're solving, we're going to divide by 2. But on this compound inequality, I have to solve all of them. So I have to solve the left side. I also have to solve the right side. So we have to divide all of the parts by 2. Cancels. 5 over 2. That's 2 and 1/2. So I'm going to call it 2.5 is less than or equal to x. 12 divided by 2 is 6. So I'm going to not quite do as good of a job on this one. 1, 2, 3, 4, 5, 6. Changed my mind. I made it up to 6. So at 2.5, we have a closed circle because our inequality between the x and the 2.5s are equal to. Between the x and the 6, it is an open circle because it is just a less than. So that's 6. And like we said with the ands, we will shade in between because it's all of the numbers between 2.5 and 6. Those are our solutions. All right, next one. A couple steps this time. Same process. Add and subtract before we multiply and divide. So I'm first going to move our 3 by subtracting 3. If I do it to one part, I have to do it to the others. Cancels. 4 minus 3 is 1, less than 2x, now less than 12. Divide by 2, divide by 2, divide by 2. 1/2, less than x, and less than 6. So on my number line this time, this is really all I need. Put up a 0, put up a 1/2, and then head over to 6. You could approximate where that is. In this case, I could probably count 1, 2, 3, 4, 5, 6 on the number line, but I really don't care how to scale that you're getting on that. Open circles at both. 1/2 is halfway, and we are shading in between for all of our solutions indicated by the shaded area. All right, that's the and compound inequalities. Switching over to the ors. Ors, use the word or, and the graph shows the solutions that make either inequality true, so not necessarily both. An example, x could be less than 1, or x could be greater than or equal to 8. That would be an example that we could see. All right. Typically, the graphs of the or statements go opposite directions, typically. So let's take a look here. First one, solve both inequalities. There they are. We got the first one. It's already solved. So we're at -3 and -5. So I'm going to put my 0 over here. -1, -2, -3, -4, -5. Counted by ones, it was small enough for me to get there. If we have a 20, just approximate where your -20 would end up. So at -3, we had a closed circle, and it says x is greater than -3. Keep in mind, greater than, we shade to the right. So shade over to my right, all the numbers bigger than -3. And then our other solutions, x is less than or equal to -5. So again, closed circle. It was or equal to, and those less thans shade to the left. So this is what our typical or inequality graph is going to look like. One's shading left, others shading right. The number that doesn't work is -4, -4.5, etc. These are not going to be solutions, but everything else is. Okay, next example, got to solve both inequalities. So we've done these a few times. Divide both sides by -6, divide -6. Oh, I divided both sides by a negative. I have to flip the sign. So now it becomes less than -3, or subtract 1, subtract 1. 2y is greater than or equal to 10. Divide 2, divide 2. Y is greater than or equal to 5. So these are my two solutions. Have to graph those on the number line now. First, I'm putting up 0. I'm just going 1, 2, 3, -3. Open circle, and y is less than, so that shades to the left. Make sure you make that very apparent. Other solutions, 5. 1, 2, 3, 4, 5. Or equal to, closed circle, says y is greater than, so that shades to the right. So typically, ors shade opposites, ands shade in between most of the time. All right, hit pause, try number 8 and 9 for the U-tries, then check back in to see how you did. All right, hopefully after the pause, you had success on these 2 U-tries, so let's see how we did. And statement first, because it doesn't say or. The x is in between, so I have to solve both the right side, left side. Add 3 to all parts. -3, less than 2x, less than 2. Divide by 2, divide by 2, divide by 2. So -3 over 2 is 1.5. So -1.5 less than x, less than 1. So it looks like we're between -1.5 and 1. So on our number line, 0, -1.5 is right here. That's an open circle. And 1 is just right here, open circle, shades in between for the ands. And that's our solution for number 8. Number 9 is an or, have to solve both. Add 5, add 5. These were the separation between the two. A is less than, negative 3 plus 5 is 2. Next step, minus 7, minus 7. Negative 2a, less than or equal to negative 5. Divide by negative 2, divide by negative 2. I divided both sides by a negative, flip the sign. A is greater than or equal to 2.5. Negative divided by a negative is a positive. So let's see here. A is less than 2. So I'm putting 0 here. 1, 2, 3, going by ones. So at 2, it's an open circle. And at 2.5, it is a closed circle. This is awfully close together. All right. At 2, we're shading left because it says A is less than 2. And at the 2.5, we are shading to the right because A is bigger. And like we said, typically the ORs shade opposite directions. So in your summary, I would want to include typically, ands shade in between, ORs shade opposite. Oh, that's a bad T. Directions. So an OR graph would look something like this. Ands would look something like this. I shaded above my number line, so it was very obvious for this here little summary diagram. All right, have a good rest of the day.